Hello, this is Peter from Educommando and a warm welcome to our STEAM project number 16, in which we will meet a very expressive frog. These lessons are for the absolute beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. In our previous lessons, we have programmed a single and a 4-digit 7-segment display. We controlled a 64 LED matrix, and today we continue our tutorials with the 2x16 LCD display. The goal of today is to display text for our frog to communicate with us. We will also introduce our class to the principles of the IIC, also known as the I2C protocol. We will install and work with more libraries, and last but not least, we will encourage teamwork in the classroom so that everyone is successful. Let us take a closer look at this popular LCD display. With 2 rows of 16 digits, we can create letters, numbers, and all kinds of symbols. There are 2 types that come with most of the starter kits. One is the simple version with just the display, and the other is a version that includes an extra module that allows for I2C communication with the Arduino. The simple version has to be connected via these 16 pins. The I2C version has only 4 pins. Those 4 pins are the ground pin, a 5-volt pin, the data pin, and a clock pin. When installing the simple version, a separate potentiometer to control the brightness of the display is needed. The other version has a small potentiometer built in that you can turn with a small screwdriver in order to adjust the LCD. This is a very versatile display, and it is often used to display the readings of measurements such as temperature, humidity, or atmospheric pressure. Regardless of the version, the LCD display is controlled by installing a library. And the one we are going to use is the Liquid Crystal _ I2C.H. We are using the Arduino IDE 2.2.1, which includes this library in the Library Manager. Yet, it is not active, so you have to install it first. Make sure to install the version from Frank de Brabander called Liquid Crystal _ I2C, because there are a number of libraries available for specific use cases, and these may not work for what we want to do. Let's distribute the few components that we need for this project. We start with the microcontroller and the breadboard, the 2x16 LCD display, a female-to-female DuPont cable, and of course the all-important cardboard frog. Depending on your microcontroller model, you may have to use a couple of jumper cables. Building the project is quite easy because we only need to connect 4 wires. Depending on the microcontroller that you have, you may have to use another connection to link the display to the digital pins of the microcontroller. Some microcontrollers have a special pin breakout that supports the I2C. Others have the clock pin and the data pin as part of the row of digital pins. Regardless, the data pin of the display will be connected to the pin with the abbreviation SDA and the clock pin to the digital pin abbreviated SCL. That's it for building the project on the breadboard. Before we let the class start with the programming, let us explain the origin and advantages of the I2C protocol. Let's take a look at our slide. So, I2C is a two-wire communication protocol that uses a clock signal and a data signal, hence the two wires that we need to connect. It is used to communicate between microcontrollers, sensors, and other peripheral devices. It can support multiple devices on the same bus, and the protocol is what we call a master-slave protocol, where the master device initiates the communications and the slave device or devices respond. It also supports multiple data rates, like 100 kilobits per second, 400 kilobits per second, and even a high speed of 3.4 megabits per second. However, it is still regarded as a slow means of communication. However, it supports the acknowledgement of data transmissions between devices. Now is the time to ask your students to connect the microcontroller to their computers and let them open the Arduino Integrated Development Environment, or IDE. At the top, as usual, we name our project Project 16, an expressive frog. The next thing is we want to include our library, the liquid crystal underscore I2C.h library. And the first thing we have to do is to create what we call an object of our display. And we do that by the following command, creating the object LCD with the address of the display 0x27 and telling the program that we are using a 16-digit by 2 rows display. The code is liquid crystal underscore I2C, then LCD, which is the name of the object that we will be using throughout the program, and in between brackets, the address 0x27, 16 digits, and 2 rows. In the setup function, we first have to initiate the LCD display by using the init command. So lcd.init and open and close the brackets. And we also need to switch on the backlight by using the command lcd backlight. That's it for the setup area. In the loop function, we tell the LCD to start at the first position of the first row. And as you may remember, within the Arduino environment, 0 is the first position. We use the command lcd.setCursor and in between brackets 0, 0, which puts our cursor to the first position to the left on line 1. Now ask your students to print something like hello and add the name of one of their teammates. So lcd.print and in between brackets and hyphenated hello Indira. Because we have a second row, your students can print another message. But first they need to set the cursor to the first position of the second row. And we do that by typing lcd.setCursor, and the position now is 0 because it's the first position to the left, 1 because it is on line 2. And they can type a message like lcd.print, in between brackets and hyphenated, how are you? ? Let them upload the program and see if that works. Of course, we can do a lot more with the display. For instance, ask your students to create a short for loop that counts to, let's say, 99, with a delay of 1 second between each count. They should be able to do this all on their own by now. The small for loop will look something like this. So we create an integer j and we set it to 0, and as long as j is smaller than 100, we set j equal to j plus 1. We include a small delay of 1 second, and then we set this cursor to 0, 1, position 0, 1, so to the left on the second row, the first digit, and we can print something like count with me, and then we put LCD print J. Let your students run the code. They will see again the name of their friends, and the friend is counting with them. This concludes our project number 16, an expressive frog. Ask your class if they believe that today's goals have been achieved. We know about the working of the 2x16 LCD display. We have experienced the usefulness of the I2C protocol to make projects easier. And most importantly, teamwork makes the dream work. There are many assignments that you can give your class. Here are some examples. Frogs, toads, and other amphibians are cold-blooded. Why do we call them like that? What are the life stages of a frog? When we look at a frog, are they born like that? Why are some frogs poisonous? These are just some suggestions. Use your own imagination and experience to assign fun tasks to your class. I hope that you and your class enjoyed this short project and that you're eager to start with project number 17. In that lesson, we are, for now, leaving the world of LEDs and displays, and we will start exploring the world of electronic motors by building a small fan to keep us cool in the class. Bye-bye for now, and looking forward to meet all of you in our next lesson.